Good morning, my lovelies. So this is my last video with you guys. Everything's going good. Went to the doctor yesterday. Everything's going textbook. They're very proud of me. So I'll see you guys after Thanksgiving. I know it broke your heart to have a snow day. Now we're behind, but we'll catch up. So we are going to, first of all, I want to thank the two girls that have texted me and wanted help. I look forward to that. Sometimes I might be taking a nap or resting, but I will get back with you. So please call or take pictures and send them to me, and I'll work something out or explain it to you. So one of them that I had a question on, I'll start with it, is number 25. I think it was 25. Square root of -4 times square root of -9. I mean, we had the old rule, old property with the real numbers. The real number property said the square root of A times the square root of B equals the square root of AB. And that kind of still holds true, but in the complex numbers, we have to realize from the get-go that these are complex numbers. So if you rewrote them like this, you'd realize you've got a 2 times a 3 times an I squared, which makes this -6. You can't treat it like you would the real numbers and take -4 times -9 because they aren't real numbers. And if any of you guys choose to go further in math, I mean a lot further, you're going to find out that not all numbers follow the properties of our real numbers that we can tangibly think about in our world. Okay? Today we're going to continue operations on conjugates, or sorry, on complex numbers. So I'm just going to go through and do some evens here and kind of not take too much of your time. Of course, I don't know if you're using your time wisely anyway, which you should be. So basically, the real parts get added with the real parts, and the imaginary parts get added with the imaginary parts. So I wouldn't write this down, but what you've got here is 6 plus 8, and then you've also got a -10i plus a 4i, and that's the way you treat it. I mean, you can do that in your head. You've got 14 minus 6i, and you're done. And do put it in that order. Put your real part first, then put your imaginary part of your complex number. I think it's a waste of our time to even do any more of the addition or subtraction. Just don't forget to, I'll do 64. Don't forget to distribute the negative sign. 3/5 minus 1/8 I minus 7/10 plus 1/6 I. You know, I know you've got your Casios and they do a lot of that for you, but it would be really good for you guys to try to do some of the stuff in your head. You know, change these tenths in your head. So it'd be 6/10 minus 7/10 is -1/10. And then the least common denominator of 8 and 6 is 24. So you've got -3/24 minus 4/24, so we get -7/24, and they're still i's. I mean, just like an apple plus an apple is an apple, or apples plural, well, an I plus another I is just a different number of i's, but they're still i's. Let's jump down to multiplication. 68. -1/6. I think you're going to like the first part of this assignment. 60 minus 30i. Just distribute, you get -10 plus 5i. Yes, it's that easy. But once we get down to number 72, we have to think about what the text was about the other day, is that before you ever begin, you've got to realize you have a complex number times a real number, the sum of a real number plus another complex number. So always get these into their I form before you do anything to them. And then you can follow your real number property right there. But pull the I out first. So this is going to be square root of 2I times square root of 13 plus square root of 5I. Now distribute. We've got the square root of 10. I times, why did I go to the right? I have no idea, guys. See, I'm just as squirrely when I'm not there. Square root of 26I plus the square root of 10, and then an I times an I is I squared. But you never leave it like that. In fact, you'll never have a power of I. You can have an I, you can have a negative I, but you'll never have a power of I because a power of I could have been changed. So I squared is the same thing. Remember that I squared equals negative 1. So you just change this to negative square roots of 10 plus square root of 26I. So go ahead and let that sink in. Okay, 74. We're going to FOIL just like normal. 2 minus 5I quantity times quantity 8 plus 2I, and literally just FOIL. But I wouldn't recommend holding numbers in your head on these, or you're going to make some mistakes. Firsts, 16. Outsides, plus 4I. Insides, minus 40I. Lasts, minus 10I squared. So you do have some like terms right there. And then this guy can become, that's a negative 1, so it'll become a plus 10. So you end up with 26 minus 36I. Let me find it. Yep. Very good. Okay, let's try 76. Let me see if I can get a little closer here. Maybe that's better. 10 minus 3I squared. 10 minus 3I quantity squared. Just follow your rule. I've said this a bazillion times this year. In fact, I get tired of saying this one. This property, a minus b quantity squared, will always be a squared minus 2ab plus b squared, no matter what, even if they're complex numbers or have radicals in them. So, first one squared, multiply them together and double it. Last one squared. If you're still struggling with that, remember you could have written it down twice and actually seen where all of the parts came from. And then minus another 30i, and then plus your 9i squared. Plus 9i squared becomes a negative 9. I don't simplify that in my head as I go because I might have made a mistake. I want to write it out just pure what it is before simplification, and then I'll go ahead and combine like terms. So we end up with 91 minus 60i. Okay, 78. 2 plus square root of negative 7 times quantity 10 plus square root of negative 7. Well, sorry, I'm trying a new camera here. It's driving me nuts. FOIL, but it would help you to rewrite this first as complex numbers. So 2 plus square root of 7i times 10 plus square root of 7i. So we've got 20. Outside would be 2 square roots of 7i. Inside would be 10 square roots of 7i. And last would be 7i squared. And you'll be able to combine like terms here, and this will become a negative 7. So 20 minus 7 is 13 plus 12 square roots of 7i. I'm looking at the book real quick to see how they wrote that. Okay, that's why I know I mentioned it last class period, but I just want to remind you, your book, this is the appropriate way. This is the proper form to write this. However, many textbooks will go like this. But don't get lazy. If they ever want the proper form, that square root of 7 has to be in front of the I. It's how many of these does it have? It has 12 square roots of 7 of the i's. 12 square roots of 7 of the i's. So this one's in the proper form. This is just written so you'll understand and be careful to realize that your I is not underneath the radical. Some people get sloppy with the radical and pull it out too far, and then they think that the I might be under it. So let's go on. Ooh. Oh, the one you get to do looks more fun. Dang it. Oh, we'll do 82. But we'll do 80 first. Negative 3 times 8 minus 3i minus 6i times 2 plus I. Don't try holding things in your head, okay, because that's where you're going to make mistakes. So just take your time and distribute. This is not multiplication. This is one group minus another group. So be careful about that. We have negative 24 plus 9i. Then we have negative 12i minus 6i squared. At that point, it's fine if you just make a note that you know minus 6i squared would be plus 6. So negative 24 plus 6 is negative 18. 9i minus 12i is negative 3i. Yep, that's correct. I'm going to come over here for 82 since we start something else on the next one. Three minus 2i quantity squared plus 3 plus 2i quantity squared. Okay, again, remember your rule right here. I get tired of having to say that rule. So, first one squared, multiply them together and double it. Second one squared, that's always going to be a plus. And then it'll become a minus because of the I squared. But first one squared. Now, if that's a minus sign, you got to be careful because everything I would do in squaring this binomial would have the opposite sign if that was a minus, but it's not. Okay? So first one squared, multiply them together and double it. So plus 12i. Second one squared. So we've got, this becomes a negative 4, this becomes a negative 4, those chuck off, wah, wah. And so we get 9 plus 9 is 18 minus 8, we get 10. I'm hoping you're enjoying this assignment. It's really not that bad. And you can put your calculator, if you have a Casio, go, it depends on which model of Casio. It's complex. That's all you get. Not that it's complex. That's the mode I need you to put it on. A lot of people, once they've had Advanced Algebra 2 or Algebra 2, just leave their calculators in complex mode. You just got to ask yourself whether your solutions are in the real number system or whether you're allowed to use the complex numbers. Of course, we're studying the complex numbers, so you're allowed to use them. Okay. So next, remember when I said you couldn't run around with your radical down? Well, kind of like just like not being able to run around with your radical down, you cannot leave and I in a denominator. So we're going to use the same process. So again, we will use, I mean, it's just like when you squared a radical, the radical disappeared because like square root of 6 times square root of 6 is just 6. Well, the same process works with an I because the square root of I, or I times I is I squared, which is negative 1. So, but we needed that OI to chuck off. So we used conjugates. This time called the complex conjugate. So basically, can't run around with not only your radical down, but your I down either. So let's just do a couple of evens here to dive in. And sorry, I hope I'm not out of lead. Okay, pause. I'm not pausing it though, because last time I did that, I accidentally stopped it. I need a pencil. Okay, I have a new pencil. Better have lead, yes, okay. So when we start on number 84, it just wants to know what is the complex conjugate and what is the product of them. So on 84, they give you 4 minus 5i. This is given. Complex conjugate would be 4 plus 5i. And you know, if you do have a Casio, you can type that in just to make sure you don't end up with an I. I mean, that's the telltale sign. If you multiply these two things together, you should not have an I. So let's try it and show how it works. We get 16, and then this OI, because one's a plus and one's minus, but the terms are just alike, they're going to chuck off. So we get plus 20i, and we get minus 20i. That's the joy of it all. And then we get minus 25i squared, which is going to become a plus 25. Wah, wah. And so we ended up with 41. So two answers here. That's one answer. And then the other answer is 41. Now, when you did radicals, they ended up with the first one squared, or excuse me, when you did normal conjugates, you always ended up with the first one squared minus the second one squared. Well, with complex conjugates, because you end up with an I squared, you still get a minus right here, but because this is an I squared and that's a negative 1, it's going to be your first one squared plus your second coefficient in front of the I squared, which is a nifty little tidbit. But while you're learning, I would go ahead and try to multiply it out and make sure you get that. Let's look at 86. 86 is just 9i. So in other words, that's the same thing as 0 plus 9i. So all you would need to multiply that by to get to your complex conjugate would be 0 minus 9i. And I wouldn't have counted it wrong if you just said negative 9i. And so when you multiply that, you get negative 81i squared, which is just positive 81. Like I just said, the first one squared, which is 0, plus the second coefficient in front of the I squared. So 9, and it's positive. So, all right. So perform the indicated operations, write your answer in standard form. So we're going to go through these because I think that'll be the best way for you to see all the different types of problems they might throw at you. 88. 3 minus 9i times 3 plus I, 9i. Now, someone like me gets real excited when they see that because they realize they have conjugates. But while you're learning as emerging algebraists, you might go ahead and FOIL it, which is fine. Sorry, I had to take a drink of Diet Coke. It's morning. Gotta love my Diet Coke. So I just look at this and I realize that I'm going to have, anytime you take A plus BI times A minus BI, you will always get A squared plus B squared, because the i's take care of that negative sign. So, but if you don't see that, so I would look at this and just say that this is 9 plus 81, 90. But just while you're learning, you might go ahead and multiply it out. 9 plus 27i minus 27i, wah, wah. And then minus 81i squared, which you know would be a plus 81, so you get 90, okay? I'll skip 90, it's too easy. Okay, let's go to 92. Square root of 5 plus square root of 7i. Okay, see what Miss Tansel just did wrong? I'll give you a chance to look at it. Oh, I can hear you guys right now telling me. I can hear O'Leary saying it too quiet to where nobody can hear him, and then taking credit when Ricky says it higher, or someone on the other side of the room says it, louder. So, you're right. I shouldn't have put my radical all the way out, and that's exactly why textbook authors do that. Miss Bose is going to tell me whether you actually figured that out. Miss Bose, text me and tell me whether they actually figured that out. I really do miss you guys. But I don't feel good enough to teach right now, but I do miss you guys. Okay, now, knowing our rules, we should be able to know that it's the first one squared plus the coefficient of the second one squared. But let's double check it. Square root of 5 times square root of 5 is 5, plus square root of 35i minus square root of, that first one would have been the minus, plus the square root of 35i minus 7i squared. That becomes a plus 7, wah, wah, and you do end up with 12. So some of you guys are going to start seeing this pattern when you have conjugates being multiplied. Basically, the oi chucks off, which gets rid of your i's, and you can't run around with your I down in the denominator, and that's why we're practicing this, because then the next problem they give you, number 94, is 5 plus I over 4 minus I. So, I want to leave the original problem. Can't run around with your I down. So we need to multiply by the conjugate. And remember, fraction bars mean grouping symbols. I say these things thousands of times. I hope you get them, Fraction bars mean grouping symbols. So I need to multiply by 4 plus I. Lots of mistakes can be made by trying to do too much in your head. So be careful with it. We should end up with 5 as our denominator, but it's always useful to go ahead and multiply things out. First, outside, 5i, inside, 4i, last, I squared. First, outside, plus 4i, inside, minus 4i, wah, wah, and last, minus I squared. That becomes a minus 1, this one becomes a plus 1, so we end up with 19 plus 9i. Now here's where I'm going to get picky. Because if you're writing it in proper form, you cannot say over as one big mark. In fact, I'll go ahead and do it just so you can see we're not supposed to. So my paper's not going to photograph very good unless I write it underneath. Okay. So as a proper complex number, you would have to write it as 19/17 plus 9/17 I. This camera doesn't focus the same as the last one, but this one's mine, so the other one I had to borrow from Miss Parks's. All right, 96. 10 minus 3i over 11 plus 4i. So I'm not going to rewrite it this time. You can do what would your conjugate be? Go ahead and say it out loud. Good job. I'm hoping you said it out loud. I'm going to pretend I'm there. So you can tell I'm missing you. Don't forget your parentheses. Be liberal with your parentheses. That was a really good way. An author, Larson, writes some really good textbooks. Larson, in his calculus book, says be liberal with your parentheses. All right, foil your brains out here. 110 outside minus 40i, inside minus 33i, last plus 12i squared. Firsts 121, outside minus 44i, inside plus 44i, wah, wah, minus 16i squared. So that'll be a plus 16. That would be a minus 12. So we end up with 98 minus 73i. Now be careful here. Watch what I'm doing. Okay? Because unless I know the denominator's not 1. So I'm going to go ahead and write it. Instead of writing it twice like I did with this one, I'm going to go ahead and write it. And 121 plus 16 is 137 in proper form. And we have 73 137ths I is how you write that. Okay? 98. 4 minus square root of 3 I to the negative 1 power. You're going to see stuff like this a lot in calculus. This isn't the easiest problem in the world. It's not hard. It's just knowing that the negative 1 as an exponent means reciprocal of. So this is the same thing as 1 over 4 minus 3i. Okay? So just rewrite it, and now you know you've got an I running around rampant and willy-nilly in your denominator, and you got to take care of it. So we got to multiply by 4 plus 3i. Be liberal with your parentheses. I'll do the numerator. 4 plus 3i. I don't think I can think anymore today. First one squared, 16. Second one squared is 9. We should end up with 25 as our denominator. Some of you guys are going to start, how about 6? Did I write something down wrong? 16. Oh, it was the square root of 3. Okay, that's ugly. Sorry, guys. It was going too good to be true. Oh, I left room there. That's good. So 16 plus 3 is 19. But if you want to double check it, 16 plus 4 square roots of 3i minus, because there's a minus sign, 4 square roots of 3i minus 3i squared, which makes it plus 3. 16 plus 3 is 19. Just go ahead and write it like that. Okay? Actually, the I should have been more right here. Okay. just a couple more. So these aren't necessarily complex number. Well, these are a combination. They're a complex number, and they're a radical. So, but first let me do number 100. 6 over 7i. So basically, you just need to multiply. It's kind of tricky because you only really need to multiply by an I over I, because that would get rid of it. It's okay to multiply by negative 7i over negative 7i, but it's only the I. Another I would make this be 7i squared. I'll show you. Negative 6/7 i's. And in proper form, that would look like 0 plus, well, 0 minus, I should say. You could have put plus and negative, but some computer platforms don't let you do that. Okay, now, if you were thinking, but Miss Dancel, I thought the complex conjugate would be negative 7i. I'm going to show you that that doesn't make any difference. You'll still get the same thing. Negative 42i over negative 49i squared, which is plus 49. Then you reduce and you get 6/7. Okay? So you get the same thing. 102. Negative 2 over square root of negative 11. Okay, this is when I said he's a double whammy. He's not only a radical in the denominator, but an I. So he's just a heathen. So we're going to multiply by the same thing again. Well, two ways you can do it again. I can just show that I'm going to multiply by another negative square root of 11. But really, that's probably not what I would do. I probably would have rewritten him as square root of 11i, and then multiplied by another square root of 11i. So either way, you'd get 11 times 11 is 121. Square root of 121 is 11. I squared over negative 2 square roots of 11i. That becomes a positive because negative over negative. Kind of took a shortcut there. Sorry, kids. Kind of let that sink in. It might look better when you see it this way. Okay, and even if I would have put a negative, I would have had negative times negative is positive, and this one would have ended up a negative, but an I square would make it a positive, so we still would have gotten it. So there's more than one way to skin a cat here. On this one, we would have gotten negative 2 square roots of 11i, and then 11i squared is the denominator, which also would have been a negative 11, so we still would have gotten 2 square roots of 11 over 11i 0 plus that to write it in proper form. Come on, focus. There we go. All right, last ones. They just want you to evaluate b squared minus 4ac, and that's going to be important in the next section. So basically, you're practicing seeing whether this is actually an important little ditty here. Let me write down the b squared minus 4ac first. The b squared, the radicand, remember the radicand is what's underneath the radical, is called the discriminant of the quadratic formula. And tells you much. Okay, well, that's for another day. I'll be there whenever we start going over that, but that's why this section is having you practice with this. So on 104, they tell us that A equals 5, B equals -5, and C equals 10. And they want you to evaluate the discriminant, b squared minus 4ac. First thing I want to tell you, and I'm getting tired of this, and I wish I had $1 for every time I said it. If I had $1 for every single time I've heard somebody square the b underneath the radical improperly, my husband and I would get to go to Africa and watch the animals in the Serengeti. Okay, so that really, really makes me angry. When you square any number, it becomes positive. B, liberal with parentheses. I don't even write them down. I just automatically would have written down 25. Okay? Minus 4 times A times C. So we've got 25. 20 times 100 is 175. Is that right? 20 times 200. So negative 175. So at that point, you have 175i, square root of 175i. 25 is a perfect square that'll come out of that. It comes out as a 5, and 25 times 7, so 5 squared roots of 7i. The cool thing is, not part of the assignment, but that tells you that these are complex solutions to a quadratic. Last one. A equals 2, B equals 4, and C equals 4. 4 squared. I noticed I didn't need to use parentheses because it wasn't negative. Minus 4 times 2 times 4 is 16. Let's see. 16 times 2 is 32. So 16 minus 32 is negative 16. So you know you've got a complex number. You didn't have to write that step. You could have went straight into 4i. Because they told us just a square root, they didn't say plus or minus, our answer is just positive 4i. If you're ever doing math and you have to choose to use the operation square root, your answer is going to be positive and negative. But when it's part of the equation, you do it exactly the way it is, and this is called the principal square root. So that's it. I expect you guys to be getting your homework done. Miss Martin is going to be bringing stuff to my house. So 1.3b is 59 to 109. And some of you guys have seen that these videos are posted and are the notes. So that's good, because if you'd rather just pay attention, and you can always go back and look at the notes or print them if you've got a printer at home, or you can log in the library or a business building or something and print them. Anyway. Turn your work in. I'm going to know who did their work. And be sure to thank Mrs. Bowes for everything she's done for you. Thank you. Love you. Over and out.